All right, good morning. How's everyone today?
Doing good.
Cool. Any questions before we talk about ODP 460 and VI? All right, send me an attendance note, please. And let's start off with ODP 460. So ODP 460, you're back to writing an entire program, so not just a function. You're doing this in C, and your program should take two arguments on the command line, add them together, print out their sum. All right. And if anything goes wrong, instead of printing their sum, it prints the word error and it exits. Okay. Pretty simple description of the behavior. Take two arguments, add them, print out their sum. If anything goes wrong, print the word error. All right. So for example, my program is called S1. If I do S1 and I say 2 and 2, it prints out a 4. That's 2 plus 2. If I say S1 and I say 28 and 91, it prints out 119. If I say S1 and I say negative 3 and 10, it prints out a 7. Right? So it just adds the two command line arguments. If anything goes wrong, print an error. So if I don't have any arguments, error. If I only have one argument, if I have three arguments, those are errors. If I have an argument that's not an integer, that's an error. If I have something that's, clearly not an integer, that's an error. Right? So pretty straightforward behavior to describe. Right? Take two arguments, see if they are exactly integers, and if they are, print their sum. If you don't have exactly two integers, print the word ERR. And so for printing your sum, use a %d \n. For printing the error, do ERR \n. And it's a main program, so you don't need a test bed. You just need to run a billion tests on your own to try all these different kinds of things that can go wrong. And so this is the same basic thing that you've been doing with scanf. The only difference is you've got two arguments. But this doesn't change the way that you process them. So if you run your program ODP 460 and you say, 23 and 19, assuming you made your main program with int argc char star argv, this is argv bracket 0. This is argv bracket 1, and this is argv bracket 2. Remember, we never want to use argv unless we check argc first. So what are we checking for here? Well, if this is the way that the person runs the program, ODP 460 followed by two things, there's a total of 1, 2, 3 things on the command line. Argc will be equal to 3. So the very first thing you can do is check argc. If it's not 3, you're done. Print error and exit. If you start trying to look at argv bracket 1, argv bracket 2 before you check argc, you're going to seg fault. So first thing you want to do, check argc. If it's 3, continue. If it's not 3, error and exit. Alright, assuming argc is 3 and you decide to continue, the next thing you have to do is decide, are each of these things exactly an integer? And this is what we use scanf for. So something like scanf argv bracket 1 the usual %d %s the name of an integer variable, and then the name of a big old character array. And this says, hey, take whatever this string is, this first argument they had, try to interpret it as an integer in a string, put the integer in num1, put anything extra in extra. Alright, how do we know if this succeeds or if it fails? How do we know the difference between those two cases?
Return value.
Yeah, check the return value. Because this will run, it will do something, but we don't know what it did, so this is where we typically say, take the return value from this and let's save it in an integer. Alright, and the rule is the following. If this thing succeeds in parsing an integer and nothing else, retval will be equal to 1. So we can say if retval is not equal to 1, that's an error. Print an error message and exit. Yes, argv bracket n is the memory address of the first character of the n minus first argument. You got it. Alright, so if argc equals 3, if it's not equal to 3, it's an error. If it is equal to 3, do your scanf. If the return value from scanf is not 1, it's an error. If it's an error, print err \n and just return. And you're done. You don't need to mess with argv bracket 2 if you get an error when you check argv bracket 1. You know, exit at that point. If you print error twice, it's not going to get you 10 out of 10. Right? Because it doesn't say print error twice. So as soon as you find an error, print error and just return. You're done. But if argc was 3, and if the return value from the scan was 1, then you want to go ahead and scan the second argument. And in this case, I'm going to scan argv bracket 2. I'm going to save the integer in ampersand num2. So you'll want to declare those as integers. And I'll do another check. If retval is not equal to 1, that's another error. Print an error, exit. If you get through all of that, argc was 3, this scan returned to 1, this scan returned to 1, now you have your two integers, num1 and num2, or whatever you decide to call them in your scan calls. And now you can do your printf with a %d \n or /n, followed by, you know, num1 plus num2. And then you're done, just return. So yes, if you wanted to grab the ith character in the nth argument, you could do argv bracket n bracket I. That's exactly right. And that's what scanf will basically be doing. Scanf is going to have to go through this thing character by character. So we'll look at argv bracket 1 bracket 0, argv bracket 1 1, bracket 1 2, and keep going and build up an integer from that. We shouldn't have to do that in this ODP, or for most of what we do until we get to maybe the last programming assignment. But yeah, that's exactly how you would sweep through the individual characters. All right, so any questions about this? All right, let's go back to VI. So I posted in Canvas just kind of a reasonable looking quick reference chart for VI. There's a ton of these out there. If you just Google VI reference card, you'll see, you know, tons of options for this. This one I liked because it was simple. It's clean, it's one page, it's definitely not complete, right? I mean, nothing would be, but it's got the basics down, right? Adding and inserting text, which we're going to talk about today, opening lines, which we'll talk about, changing text, It's got the copy and paste stuff that we talked about yesterday, deleting text that we talked about, moving around, and so on and so forth. So this isn't a bad starting point. And some of these commands are different from what we did yesterday. I used an uppercase Y to yank. They use 2 lowercase y's, right? It's the same thing, right? Bunch of ways to do all of this. But my suggestion is, if you want, download something like this or find one that you like through Google, and keep that handy. But start making your own cheat sheet, right? Just get a piece of paper and mark VI on the top, and when you discover a command in VI that you like, that saves you time, that seems useful, just jot a little note for yourself. Use post-it notes or something if you want. And then over time, the stuff that you use a lot, you'll internalize, you'll remember. The stuff that you never use will end up down at the bottom of your pile of notes or something, and forget about it. Not a big deal. So you don't have to memorize these, right, or force yourself to use these. I'm not going to ask you on tests about VI commands or things like that, but use it in a way that helps you. All right, so let's see. We got through some VI yesterday. We got through moving around, deleting, some miscellaneous commands. I think we left off at inserting. So let me make a test file, and we'll go into to VI. So most people, when you want to insert, what do? You type an I. So if I want to put something right before here, I'll type an I, and I can start typing, and whatever I type inserts right before my current cursor location. So one thing I'm doing is, as soon as I'm done inserting, I'm hitting escape. I'm not even thinking about it, right? So that if I want to start moving around, I can start using J or K and so on. And if I want to insert the word many here, I type in I, many, and I hit an escape. And hitting escape can be just kind of a thing you do when you're trying to think, right? It doesn't do anything if you're already in command mode. But you want to make sure you're in command mode before you start typing, because if I'm in insert mode and I want to delete 5 lines, I'm going to do this, and I'm going to join a line, and I'm going to add something, and I've got all this weird stuff in my file now, right? So you want to be cognizant of what mode you're in, and I think the easiest way to do that is just always stay in command mode except when you're inserting. When you're inserting, you're typing stuff. When you're done, hit an escape. Alright, so we're in command mode. We can insert before our current location by typing an I, and what we type goes in before. If you want to add to the end of a line, insert doesn't work, right? If I type an I and I start typing, it's going before that period, and I want to actually insert after that period. Alright, so you can use an A for append. So A says this gets added after my location. And if I want to move this over one spot, I can use B to go back. I can say I space escape, and now I added a space in the beginning. Alright, so I and A are useful. And if I wanted to add something after my location in the middle of a line, right, I can still do that. So if I'm down here at the equal and I want a space after that, I can just say add space. And if I want a space before, I could say I space. So A makes things appear after the cursor. So if I type in lowercase a, this is right after the equal. Let's use the A command. And if you want to place before the cursor, you use an I. So if I want to insert right before history, I could say, you know, old history. So I and then type and then hit an escape. And absolutely the way to get familiar with these is just to go into a file and just start using these commands, right? It's not a spectator sport. It's really boring watching somebody else use VI. And when I was learning Linux, my mentor Larry, he was getting into VI, and I'd be doing something, and he'd be like, "Oh no, you can do that more easily." And he'd start trying to like tell me how to do it, and I wouldn't understand it. And eventually, he'd grab my keyboard and he'd start typing for me. And half the time, something would mess up, and he'd be like, "Oh, wait a minute, hold on, let me fix that." And I'd just kind of be sitting there watching him do this stuff, you know. And then when he was done, I'd just like, you know, be amazed that this worked, but you know, it worked. Just pressing I twice turn from insert to overwrite. Nope, if I press I twice, what's it going to do? It's going to insert an I. Because once you press an I, you're in insert mode. Once you hit an A, you're in insert mode, but you're starting after whatever your position was. If you want to overwrite text, you can use Shift R. So Shift R puts you into replace mode. It's like overwrite mode in Notepad or something. And whatever you type replaces the text that's already there. And that's actually useful sometimes. So that's an uppercase R. Alright, sometimes you want to start a new line above or below your current location. So if I want to start adding something after this line that I'm on right here, I can just use a lowercase o. That means open a new line and I can start typing here. If I want to insert something before my current line, I can use an uppercase O, and that opens a line above me. And insert might work. Some of the keyboard keys will work. Sometimes they won't. The keyboard characters, Shift R for overwriting, I for insert, A for append, these are always going to work, right? Pretty much no matter what VI system you get into. And if you have a keyboard that has no keypad on the side, doesn't have these extra keys and so on, you can still use VI, right? So that's useful as a fallback or a main way. So R will let you replace, lowercase r will let you replace a single character. So if I wanted to replace this equal sign with an exclamation mark, I can just say R, and whatever I type replaces that. So that's useful for replacing a single character, and then Shift R replaces, you know, multiple characters, however much you type. So if we want to change a word, you're cheating, you must be looking at my cheat sheet here. If we want to change a word, we can use CW. So for setting history length, if I want to change length to something else, I can say CW, and I can just change that to len. Right? And when you do CW, it shows you a $sign to let you know where the end of the word is. But you know, if you type something bigger than that, that's not a problem. If you type something smaller than that, that's not a problem. But it's showing you the thing that's going to be replaced. I've never intentionally hit the function keys in VI. I don't know what they would do. F1 seems to bring up help, so that's good. F2, 3, 4, 5, 6, 7, 8. So my function keys don't seem to do anything except F11 makes you full screen as usual. But you could set them up, I'm pretty sure. So one of the things about VI is it's pretty standardized, but it's also customizable. And if you customize it, that's great. That can make you more efficient. But then if you find yourself in an environment that doesn't have your customizations, right, then you got to set those up. Usually not a big deal. But sometimes it's nice to know how to do things with just a base VI setup. Alright, so remember DW deletes a word, and then CW changes a word. You can set your history length in Bash to record commands. And it sets how many, oh yeah, right there. It tells you how many commands you can recall. So if you use the history command from Bash, you'll see, in my case, the last 1,000 commands that I executed. I don't know what the difference is between these two. Presumably I did because I set them up.
It seems like my CW isn't as cool as yours because mine doesn't have the $sign at the end.
Oh really?
Where it's going to replace to.
Oh, that's weird. I don't know why that would be. I've never seen it not do
Yeah,
that.
mine just deletes the word and then, you know, it's the same thing. It's not too big a deal, but I just wish mine was cool.
It might be something that's set up in EXRC. Did you download that file to do like arrow keys and stuff?
No, this is just a standard vim I got.
Interesting. See if there's an EXRC or a vimRC, because there might be something set in there to change that.
Oh, actually, further development, this is the Linux servers VI.
Oh. Well, let's mess around on there. Oh, that's weird. Oh, yeah, so I downloaded this configuration file that I tell people they can download on their machines if they want the arrow keys to work. So if I go into insert mode, the arrow keys still work in here, because that seems to be what people are used to. But if I move that out of the way, nope, that still does that. That is strange. I don't know why it does that. I'll dig into that at some point. Yeah, I never noticed that. Weird. Alright, that's cool. Alright, let's see. I think hist file is 1,000 means 1,000 commands. But I'm not sure. Like I say, I must have known it sometime because I set it up. But I don't remember. Alright, so searching. So searching is a powerful feature, right? Really simple to search. Type a slash followed by what you're looking for. So if I'm looking for the word this, right, this will move me to wherever in my file the next occurrence of that string is, THIS. If I want to search for the same pattern again, I can just hit an N and it'll repeat the search. And each time I hit N, it shows me the next occurrence of that pattern, and if I get to the bottom and it wraps around, I get a message saying search hit bottom, continuing at top. So if I look for echo, right, there's an echo, there's an echo, there's an echo, and so on. And then eventually it goes back around to the top. If you want to search backwards, you can use a question mark instead of a slash. And if you've already done a search with a slash or a question mark, but you want to search in the opposite direction, you can do a shift N to move in the opposite direction. Alright, and then there's a command line. And Bash has a whole bunch of things that you can do after you hit a colon. So if you're in command mode and you hit a colon, you pop down here on this lower line, and usually this is where we do something like, you know, write. But we can do other things from here also. let's see. Bash question in chat. Install script for a function into bash aliases. So you could define a function inside your bash RC file, and then you could use that anywhere in your bash session to do whatever it does. Or you can make an alias to a bash script and do the same kind of thing. So colon W can take an argument. So I could say colon write to backup, and now I've created a new file called backup. I'm still editing the file test, but if I look in my directory, now I've got a backup file, which is a copy of test. So colon W will take arguments. I can also say colon VI to start a new VI session. So I could say VI header, and let's create a header file. Alright, so that's what I want to put in the top of my programs, right? Something with my name and the date. Alright, so that's a file called header. If I want to go back to the last file that I was in, I can do a Control 6. I don't know why, that's the weirdest escape sequence I know. Control 6 switches between the last two files that you were editing. And it turns out to be really useful. I don't know if colon WQ new file would save and then quit or not, but give it a try. That's the nice thing about working on computers is the computer knows the answers to all our questions, and it's a really good habit to get into of using the computer to try things, right? And you might discover something that you didn't know and that your friends don't know. Or you might discover something totally different from what you thought you were trying to do. So yeah, definitely explore and see what happens. Just don't do it, in your main directory with your final version of your code 10 minutes before you're about to turn it in, right? Make a junk directory somewhere, make sure you're in that directory, and then just go crazy and explore. Write files, use weird commands, all that kind of stuff. Alright, so let's say that, that header file that I have, let's say I want to put that in the beginning of my script here, right? It's not a bash header, but that's okay. So I'm going to say :r space header. And this will read the contents of header into my file right below the line that I'm currently sitting on. And there you go, there's my header. Now I really wanted it to be in the very beginning of my file, so I'm going to undo that. I'm going to do Shift-O to open a line, and then I'm going to repeat my read header command, and then I'm just going to go up here and DD to delete that. And maybe I'll do an O down here to make some space below, and now my header's inside my file. So you can write that thing once, and then just pull it into your other files. So that's :R, and it inserts it right below your current line. So if I'm down here and I say read header, it'll go right below that spot. So it basically opens a line below you and then pulls it in. Alright, you can also do : and run a Unix command. So if I want to see what files I have, I can do a : ls. And I got 3 files. If I want to see a full listing of my files, I can do : ls-l, and I can see, oh, this header's only 81, and this test file was created after my backup, and so on. Right? So you can do any command you want. I think you could probably even run VI. That would be weird. So that's : If you want to execute a command and pull the results of that command into your file, you can do that. So I could say something like, files in this repository are, and then I can say :read !ls-l, and then I can put my ending comment here, right? And now this is, you know, part of my file. Or if I wanted to put the date in, I could come up here to where it says date. I could say :read !date. I can come up here. I can do a Shift J to join. Now I got the date in my header. So all kinds of possibilities like that. Alright, let's see. Command line. Anything else I want to tell you there? Alright, so those are pretty useful. We can use this VI command line to do things on a particular line. For example, let's search for don't. Right, so I'm here on this line that says don't. I could say : substitute don't with do not. So :s is a substitute command, and everything between these two slashes is the thing I'm looking for. Everything between these slashes is what I want to replace that pattern with. So this should replace the word don't with the word do not. And I can specify a range of lines that I want to do that over. So for example, I could say from the beginning of my line to, and $ means the last line of your file. So for every line in my file, let's substitute don't with do not. And it made 4 substitutions. So there were 4 spots where it said you don't need to enable this, and so on. So you can start doing like large-scale changes to your file, and this can be useful / dangerous for things like, you know, you want to change a variable name. Now, if you want to change the variable name from I to counter, don't just substitute every occurrence of I with counter, because, you know, I pops up in printf and so on and so forth. But within reason, you can use this and do some good things. So I use alias commands a lot of places. Right, I do a lot of aliasing of things. Maybe I want to do something different from aliasing. Maybe I have my own alias function that's going to do something in addition to aliasing, and I want to change all of these to be my alias. Right, I could do this, substitute alias with my alias. And now all of those are changed. We can delete. So here's line 379, and here's line 383. So I could say : 379, 383 delete, and it'll take out those lines. Or I could come down here and I could say : 373, my current position delete, and it would delete everything from that hashtag GeoWave down to where I am right now. Or sorry, that alias. Or I could delete, you know, everything from the beginning of my file to the last line, right? That gets rid of everything. And I'm using a lowercase u to undo those, by the way. And this is really just kind of lifting the lid on Pandora's box, but a good, friendly Pandora. This is the entryway into a future discussion about regular expressions, and looking at ways that we can find patterns and manipulate patterns based on what's in them. So, for example, when I do attendance stuff, right, in the beginning of the quarter, I download a list of students from Canvas, and they come in with, you know, first name space last name. With a single VI command, I can change that to be your first initial in lowercase, followed by your last name in lowercase, followed by a comma, followed by your last name, comma, space, first name, if I wanted to do that. right? And it's just one of these, you know, substitute slash, and then you put in what are called regular expressions over here, and you can do all kinds of manipulation. And manipulating text is a big part of what we do, because, you know, everything's a file, but we can change formats pretty easily. So we're going to talk about regular expressions later in the course, probably around week 7 or 8. Command for zooming out to see more lines. Well, on my system, I can control scroll wheel and do that, or I can get into late night mode and not have to have my glasses. And I think that might work in PuTTY also. I'm not sure. This is a really awkward way to edit. Alright, now I gotta undo that.
It's funny, that almost seems counterproductive.
I know, right? I know there's a better way, but I don't know what it is. All right, so let's see. Anything else I want to tell you at this point? That's probably a good stopping point for VI. And like I say, you know, this is not the final word on VI. This is not even like, you know, the early words on VI. But stuff that we can do. All right. So let's. Any other questions about that? All right. Do an attendance ping for me. This will be one of those rare 3 attendance pings for the day. Hey, good timing.
I didn't know if we had done one yet or not.
I think we did one earlier, but we'll do another now. We'll do another at the end. All right, so let's talk about debugging. So you know, you write code, and the code you write is an implementation of an algorithm that, you know, you or somebody has come up with to do some task. So you want to, you know, calculate averages on a test, or you want to record, you know, who was present in class based on attendance pings, or you want to be able to go out to a website and look at pages. Whatever it is you're trying to do, there's coming up with an algorithm to do that, right? And then there's converting that algorithm into a set of steps that a computer can do. That's what writing a program is, right? It's translating from your view of something to a view that the computer can understand. And theoretically, that's a one-way process. You sit down, you write the code, you compile it, you give it to the computer, it runs, you're done. In practice, right, it's usually not that easy, because we make mistakes. We sometimes make mistakes in algorithms, we sometimes make mistakes in coding those algorithms. But the end result is the same. You run your program and it doesn't do what you thought it should do, what you think you told it to do. It's doing something different. Okay? So that behavior, that's called a bug. There's a bug in your code. It's something unintentional, and it's something that's causing an undesirable change in the behavior of the program. So debugging is the process of taking that bug out of the code, which means first you have to find it, and then you have to figure out what to put in the place of the buggy code to make the bug go away. And debugging is inevitable, right? No matter how long you code, there's going to be bugs that pop up, because, you know, we're human. We make mistakes. We code at 3 a.m. after being up, you know, 21 hours, and we get distracted, or, you know, things change. We've got a piece of code that's working with another piece of code, and that piece of code has changed, or the operating system has changed. or the clocks just rolled over from 1999 to 2000. And so bugs are inevitable, and you want to be able to avoid bugs as much as possible, but you really want to be able to find bugs and debug code. It's a vital skill, and it's a skill that will be very valued by others on your team, by people in the workforce, and so on. So it's a good thing to develop. And this brings me to a kind of paradoxical statement, which is having a bug in your code is not a bad thing. It's actually a good thing. In college, because we're in college to learn, right? We're trying to get better at programming. Bugs are huge learning opportunities. Because what happens when there's a bug in your code? It means that you wanted to do X, you wrote code to do X, and the code did Y. Right? It did something different. Well, there's a learning opportunity. Something that you misunderstood, something that you forgot, something that you thought worked one way but it works slightly different way in this situation. Something, right? If you figure out why this code that you think does X instead does Y, you're going to learn something. Okay? And the longer it takes to find that bug, probably the bigger the thing you're going to learn. So my advice is, when you're writing code and it doesn't work, don't just start changing things at random. Don't Google to try to find how to fix it. Don't delete it and start over again, right? Debug it. Take it as an opportunity to say, hey, there's something in here that if I figure this out, I'm going to learn something, I'm going to be a better programmer. Go with that, okay? Now obviously, if you've got a deadline, if this has to be done in 10 minutes, then maybe you just want to start changing things and try to get it to work. But that's uncomfortable too, because getting something to work in one case doesn't necessarily mean it's going to work in other cases. Yeah, bugs can be cooler than intended features. The joke always is, it's not a bug, it's a feature. And sometimes that's true, right? Sometimes your code does something you didn't expect, and it turns out to be like, that's actually really cool, and you can turn it into something. So embrace your bugs, right? Don't run away from them. Use them as opportunities. And so how do you debug? How do you find a problem in your code? Let's say you do something like integer x equals 0. Well, x is less than 10. If x equals 5. Right? So you got a piece of code, and you want to know what this is. This is supposed to add up the numbers from 0 through 9 and print a message halfway through, right? And it doesn't do that. It gives you some weird answer in the end, right? So the first thing you can do is you can debug this by yourself without a computer, without GDB or anything else. You can debug this on paper. And the way you can do this is what I call playing computer, right? Which basically means just pretend you're a computer. Pretend you're the computer that's running this program. And so how do we play computer with this? We sit down and we say, okay, integer x equals 0. Okay, here's a variable x that's equal to 0. Integer sum. Okay, here's a variable sum. I don't know what it's equal to, so write a question mark. While x is less than 10, what's the value of x? 0. It's less than 10. Okay, I'm going to go on to here. Sum equals sum plus x. Well, I don't know what the value of sum is right now, so when I add x, it's still going to be unknown. So right there, you're seeing a problem, right? I wanted my sum to go from 0 to 1 to 3 to 6 to 10 and so on, but it's got an unknown value, right? I forgot to initialize it. Okay, put that in, test it, you run it, it doesn't work, so play computer again. Okay, x equals 0, sum equals 0. Well, x is less than 10. Yeah, x is 0, that's less than 10, right? Sum equals sum plus x. Okay, sum will just be 0. If x equals 5, it's not equal to 5, it shouldn't print hello. But when I run my program, it prints hello, right? But I don't know where it's doing it. Okay, so you can do this provided that you can faithfully see what the code says. And that's hard to do sometimes. Because when you write something, you tend to see what you think you just wrote. When you type an essay and you try to proofread it, it's really hard to actually read word for word. What you end up doing is you end up reading what you think you put on the page. And so there's a sentence where two words are swapped with each other, and you read it, 10 times, and you don't see that those words are swapped, because you're reading what was in your head when you put those words down on paper. Same thing here. This is an if statement. If x is equal to 5, print hello. But it's not an if statement, right? This is an assignment statement. This says set x equal to 5, and then if this is non-zero, which it is, go ahead and print hello. And so the first time through this loop, x changes to 5, x gets set equal to 6, it's less than 10, it adds 6 to sum, this sets x equal to 5 again. This is doing something completely different from what I meant. But that's really hard to see by just staring at this, because chances are when I stare at it, I don't see the single equal sign. I see if x equals 5. I see a comparison between x and 5, because that's what I had in my mind.
But
So
that's
this,
not going to really generate any errors, huh? Because technically that is a true statement.
that's a totally valid statement in C. It's not going to give you any errors. So this is what I call the hardest bug to find in C, right? And so this is where GDB will come in. And GDB is a tool that we can use to execute our C program, and if we like, we can execute it one statement at a time. And after each statement, we can print the values of variables, we can call functions, we can change the value of variables. And if we run this in GDB, right, we're going to go through and we're going to get here, and x is less than 10, so it's going to go into our loop, it's going to set sum to 0, that's fine. Here's the if statement. The next thing that's going to happen is it's going to print hello. And right there we're going to say, wait a minute, it should not be doing this until x is 5. And we'll print the value of x, and we'll see that x is 5. And we'll say, how did that happen? X was 0 up here. Well, then we can put a watch on x. We can say watch x. And anytime x changes value, it'll tell us. And we'll go back to the beginning, and we'll start stepping through. When we get to this if statement, it will say, hey, x's old value is 0, new value is 5. And that'll trick our minds. That'll be our trigger, and we'll say, oh, I can't believe I did that. That's an assignment statement. Should be a double equal. So GDB will work with us, but we're still going to have to, know what our program is supposed to do, and in a lot of cases, go through and pretend we're a computer. I want this to happen. I want this to happen. GDB tells us what actually does happen, and eventually there's a disconnect, right? I want to go back to the top of my loop. GDB is not going to the top of my loop. I want to exit my loop. GDB says I did not exit my loop. I want x to get incremented. GDB tells me x was not incremented. Right, so that will help us with that, and we're gonna say again.
This is kind of like the software version of like MPLab, right? Where
Yeah.
checking the outputs and inputs, so it's kind of the same thing.
Yeah, this is exactly what the debugger in MPLab does. It's the same thing. So GDB is the GNU debugger. GNU is an acronym for GNU is not Unix. It's part of Linux. So this is a standard debugger. You can find it in pretty much any installation of Linux. And so this is similar to rubber duck programming, right? Where you go through and you try to explain your code to a friend or a rubber duck or a dog, right? And the process of speaking out loud what the program is doing will sometimes help you see, okay, and then I check to see if x, oh, wait a minute, I'm assigning it to 5, right? So that's a way to break out of the mindset of just staring at your screen and seeing the same thing over and over and over again. So kind of like rubber duck.
I guess technically you missed some semicolons too.
Yeah, I did, and I didn't use a valid print statement.
Yeah.
So what we'll do tomorrow is we'll play around with some code in GDB that has some bugs in it, and we'll see sort of how we can step through things with GDB. And GDB has, you know, a zillion commands to it and all kinds of ways you can customize it. We're going to go through, you know, like 5 or 10 commands, that's it. But it will be enough for you to do a lot of debugging. And my hope is that, you know, PA3 I'll post tonight. We'll talk about PA3 tomorrow. And as you work on PA3, which is a C program, you can use it as an opportunity to start exploring some of these things, different ways to use VI, ways to use GDB to help you find your bugs, and so on and so forth. So we're going to start, you know, building up our toolkit of Unix tools. We're going to talk about makefiles next week, which will be part of PA3, and we'll have a good time with all of that. Wave dashing in Smash Brothers. It's a bug. That's cool. All right, good. We are out of here. Have a good afternoon if I don't see you in 2:15. Have a good day, and I will see you next time.
Did I miss a attendance game?
I did one in the beginning. I did one halfway through. So if you didn't send me one now. But we're good to go.